Hello friends, I welcome you in lecture number 5 on complex differentiation. In this lecture, we will discuss about differentiability of one more complex function, which is function given by f of z equal to conjugate of z. We are already familiar with the definition of conjugate of a complex variable. We know that if z is a complex variable given by x plus iy, then conjugate of z is denoted by z bar and is obtained by replacing I by minus I in z equal to x plus iy. That is, we obtain z bar as x minus iy. So we are going to determine the points in the complex plane at which this function is differentiable. So we are going to prove that this function z bar is nowhere differentiable, or it is not differentiable at any point in the complex plane. They can ask the same question in different ways. They can ask in this way also: determine the points at which function z bar is differentiable. And as we have discussed in earlier lectures, we are going to use Cauchy-Riemann equations to prove that z bar is nowhere differentiable. So first step is we have to find out real and imaginary parts of given function. Here given function is f of z equal to z bar. So first we write down given function, then we take z equal to x plus iy in f of z. Let z equal to x plus iy. Then what is f of z? F of z is z bar, that is conjugate of x plus iy, which is x minus iy, and we compare this with u plus I times v. Suppose this is equal to u plus iv. Then if we compare these two, we have u equal to x and v equal to minus y. Therefore real part is u equal to x and imaginary part is v equal to negative of y. Then next step is to obtain first order partial derivatives of u and v. Here del u by del x is 1 and del u by del y is 0. v is minus y, therefore del v by del x is 0 and del v by del y is minus 1. Now we know that Cauchy-Riemann equations are del u by del x equal to del v by del y and del u by del y equal to minus del v by del x. So our interest is to determine the points at which del u by del x and del v by del y are equal and del u by del y and minus del v by del x are equal. First we check for this equation. Here del u by del x is 1 and del v by del y is minus 1. So both are constant functions. Del u by del x is 1, that means at any point xy in the complex plane, value of del u by del x is 1. Similarly, this means if we obtain value of del v by del y at any point in the complex plane, then it is same constant minus 1. Therefore, we can say that these two functions are different at every point in the complex plane, or we can say that del u by del x equal to del v by del y is not satisfied at any point in the complex plane. So here we write that del u by del x is not equal to del v by del y, and this is at every point. Both are different at every point z equal to xy in the complex plane. In the complex plane, these two are different at every point in the complex plane, or we can say that del u by del x equal to del v by del y is not satisfied at any point in the complex plane. And we don't have to check for second equation, because for differentiability we require that both Cauchy-Riemann equations are satisfied at a point. And here we can see del u by del y is 0 and del v by del x is 0, therefore minus del v by del x is also 0. So it is clear that del u by del y and minus del v by del x are equal at every point. At every point their value is 0. So this equation is satisfied at every point. But this equation is not satisfied at any point. Therefore we can say that there is no common point at which Cauchy-Riemann equations are satisfied. Therefore we can say that both Cauchy-Riemann equations, or we can shortly write CR equations, are not satisfied. Both Cauchy-Riemann equations are not satisfied at any point in the complex plane. One Cauchy-Riemann equation is satisfied at every point, another Cauchy-Riemann equation is not satisfied at any point. Therefore there is no point at which both Cauchy-Riemann equations are satisfied. And if Cauchy-Riemann equations are not satisfied, then we can say that function is not differentiable at any point. F of z equal to z bar is not differentiable at any point in the complex plane. Is not differentiable at any point in the complex plane. In other words, we can say that f of z equal to z bar is nowhere differentiable. This we can write in this way also, that is z bar is nowhere differentiable. So here we obtain one function which is not differentiable at any point. If you recall, in previous lectures we have discussed these functions f of z equal to z square. This was differentiable at every point, or we can say that z square is differentiable everywhere. Then we discussed the function given by f of z equal to square of modulus of z, and this was differentiable at only one point, that is z equal to 0 or origin. And in this lecture we have discussed f of z equal to z bar, and this is differentiable nowhere, or it is not differentiable at any point. So remember, all these are standard or important functions. We are going to use them repeatedly in upcoming lectures of this series. So this is all about this session. Here we have discussed that function z bar is nowhere differentiable using Cauchy-Riemann equations. Thanks for watching.